Hi everyone. Welcome to MentorHealth's live webinar on working with chemicals, hazards, and control measures. My name is Liz, and I'm going to be your host today. On behalf of the MentorHealth team, I would like to thank you for being part of this event. Today's webinar will be presented by Michael Ellerby. Michael is as being a chartered safety professional and a chartered member of the Institute of Occupational Safety and Health. Mike is a chartered chemist and scientist, as well as a degree in chemistry. He also holds a degree in law. Mike runs his own health and safety consultancy and has also acted as a competent person for the University of Sheffield, England. Mike is a CIEH certified trainer who has written and delivered various training courses. He has acted as a technical author, consultant editor, and reviewer of a wide range of safety publications for companies such as Kroner and Walters Kluwer. Recent and current clients include Brush Traction, the Carden Center Group, the Sweet Group, and the British Library. He is now the Director of Health and Safety Consultancy, which is involved with a diverse range of clients. We are really honored to have such a distinguished person such as Michael Ellerby with us to present this webinar. Ladies and gentlemen, before we begin, I would like to inform you of the program outlined for this training session. This webinar is for 60-minute duration. First, Mike will take you through today's webinar, highlighting the area that will be covered, and he will then share with you his presentation. I would also like to inform you that all participants, once they're part of this teleconference, have been placed on mute and will remain so until the Q&A begins towards the end of the webinar. This is for the purpose of avoiding discontinuity and for allowing the presenter to speak clearly so that everyone present can take maximum benefit from this webinar. I also request all to hold back your questions until the Q&A window begins. 10 minutes of time will be allotted for the Q&A, during which your questions will be answered. And if for any reason you get logged out of this training session or teleconference, ladies and gentlemen, I request you all to follow the same procedure to join in again. Now that we are all ready to start, I request Mike to take it from here. Mike.
Hello. My name is Mike Ellerby, and thank you very much, Liz, for that excellent introduction. What I'd like to do is give you a talk through working with chemicals in the workplace, the hazards associated with those, and the control measures to be considered. The approach I'd like to take is a risk assessment-based approach, which starts with the concept of understanding and assessing the risks, deciding what precautions are required and implementing those precautions with a view to prevent or adequately control exposure to the substances, then make sure those measures are in place, carry out workplace monitoring and health surveillance if required, and share information with our employees. One of the first questions to consider is what do we mean when we say chemicals? It means a lot of different things to a lot of different people. Here are some examples. We can consider solvents as chemicals, and we can consider acetone as a particular example of a solvent. Lots of people would consider acids to be chemicals. We could have sulfuric acid or hydrofluoric acid as options. People will consider resins as chemicals, in which case we've got materials like styrene to consider. Then we've got paints and varnishes, where we may have solvents like xylene. Water treatment chemicals start to come into the show. These are usually hidden behind the scenes in many of our buildings. Things like sodium hypochlorite are in there.
Mike, just a moment. Are you not moving the slides, Mike? I can't see your slides moving.
It should be on slide 3 now, Liz, which should be examples of workplace chemicals.
Yes, Mike, I'm not able to see that you're moving the slides. Just a moment, Mike. just a moment.
Cheers.
Just a moment, Mike. Yes, Mike.
I'm now
it's
the
working. All right, Mike.
Yeah.
Yes, thank you.
That's fine.
Yes, Mike, you can go on.
Okay. Yeah, so we have water treatment chemicals, which are often hidden behind the scenes. We need to consider oils and greases as examples of chemicals. Cleaning materials. Now, for a lot of people, cleaning materials, again, are innocuous materials that are around and about. So these may include materials like bleach, and then there are common dust and more hazardous dusts such as silica. These are all chemicals that can be found in a variety of different workplaces. Other examples might include epoxy resins, wood dusts, various fumes from processes like soldering. We can have aerosol lubricants and dewatering materials such as WD-40. We can have caustic soda, even fumes from vehicle engines, so we can have diesel exhaust fumes coming into the workplace. Now, we may not consider latex gloves to be chemicals, but a slightly broader area that we're interested in are substances hazardous to health. And quite a lot of people do have an allergic response to latex, and it's understanding that we shouldn't ignore that as part of the process. There are also, in certain processes, isocyanates. These are very strong respiratory sensitizers that we need to protect people from. We can have welding fumes, which may or may not contain chromium, depending on the kind of materials that we're welding. Used engine oils. While new engine oil is a relatively innocuous substance, used engine oil can indeed be a cancer-causing material, particularly causing skin and testicular cancer. Now we can have materials like cement. These are very good as skin sensitizers. And as I said earlier, just general dust can be hazardous materials within our workplaces. We may not classify them as chemicals, but they are materials that people can be exposed to. What I've tried to do there is just give you a brief guide to some of the substances that we should be considering. I'm going to come on in a minute and show you a series of slides with some examples of those substances being shown. I want you to consider the hazards, both the hazards that are seen, which tend to be fairly obvious, and I'll point out on a couple of occasions some implied hazards. And we'll come back and look at a few of these. So here, what you can see on this slide is a material described as chromic acid, chromium trioxide, and you can see the type of way that it's being dispensed here. There's a drum of the material and some scoops in it. You should be able to see that the scoops are covered in the chromic acid material, and those of you with good eyesight will probably identify that this is classified as a toxic material. If we look at the data sheet for chromic acid, we will find that it's a strong oxidizing agent. It may cause fire or explosion. It's toxic if swallowed, toxic in contact with the skin, causes severe skin burns, may cause allergic skin responses, fatal if inhaled. The list goes on, including phrases such as may cause genetic defects, may cause cancer, suspected of damaging fertility and causing harm to the unborn child. It's clearly a very unpleasant material. It's widely used in the electroplating industry. And if we just stick with this example for a minute, people are putting their hands into there, probably wearing gloves, and handling the material quite freely, and then contaminating other surfaces from the gloves. And potentially we're getting exposure to this hazardous substance from a simple process of dispensing. Here's a sort of fairly common example of what we might find in a laboratory setting. What we should consider here is we have no idea what's in these test tubes. We have no idea at this stage whether they're toxic, unpleasant, safe, or very, very dangerous.